Hi everyone, and welcome to this 12th episode of the Git series, the series where we try to implement Git in Scala. And today we are going to look at Git index. Last time what we did is that we reached the first milestone. We were able to write a Git object, blob object, and read it back with Git after. So that was the first milestone of this series. And today I wanted to go a bit further. So to give a bit of a background here, the next thing that I would like to look at is to save the tree, save the current tree. So there are three types of objects in Git. There are the blobs. So the blobs are the object that we already looked at. There are the trees. That represents basically the directories with all the files and the directory, like the file system, basically. Here is an example. For instance, you have the git ignore, the readme, and you have other directories that are also trees. The other files are blobs. And lastly, you have the commits, and we are going to look at the commits in the next chapter, I guess. And it sounds like the first thing that we need to do is to look at the Git index. And what is the Git index? The Git index is something fundamental in Git. It allows to basically track the files that are staged. So there is a nice schema here by GitHub blog. So we can see here the directories and the files. When you run the command git add, what's going to happen is that it's going to update the index file, and once then you want to commit, it's actually going to write a commit object, and that's globally what the index is used for. The index is a file in the .git directory. So if I look at that, if I do ls.git/index, and we can try to actually print it, but it's actually a binary file, so we won't be able to see. I need to say yes, I guess. So you can see that this is a binary file. We can still recognize some text here. It seems to be corresponding to the files, and other information that we can't really understand. So in this episode, I'd like to try to start to see how we can read this git index file. I'm going to focus on read. And as we say, it's a binary file. So the first thing I was thinking is that we can potentially use this library here. So I've never used it, but it sounds to be a library that is able to work with binary data. So what I suggest today is that we'll take a look at this and see if we can decode this index file. Now the next thing is the git index format, and so the git index format is described here in this website that I believed I put in the readme. Let me see. So there is still the documentation that I complete as I learn things about Git. So here is the reference that I have here. Unfortunately, this reference is not very clear, I found. So I might be struggling a bit during this episode. I have already kind of done enough exploration about that, but I guess we'll see. Now, the format of the Git index is so it starts with DIRC, stands for dir cache, and then there is the version and the number of index entries, and then so this is the header basically, and then there is a number of sorted list index entries and potentially extension and the hash checksum. So the index entry then has a bunch of 32-bit information that we are going to try to decode at this stage, and that's it. So I'm gonna open the file that I've created for that, and I'm gonna see if it compiles. So looking at the documentation of scodec here, we can see that we basically define combinations of pre-built parses, I guess, or codec, however you want to call them, and then you try to decode or encode them. And there is also a way to have a case class binding to it, which might prove useful eventually. Okay, so we are going to be interested in the integrals types, and so the format is 32-bit second. So the question is, I don't know if they are actually signed or not. Okay, so we can see that my test is passing, and we have the size of the file is 3,400 bits or bytes. Sorry. Let's start by see if we can read the headers. So the headers is the DRC and the current version and the number of entries. So we need to find string. Okay, so it sounds like the right one here is the UTF-832. UTF-832, followed by, like, repeated 4 times. So let's repeat it for the moment and see if there is a way to improve it afterward. That's the 4 first letter that we have here. Then we have the 4-byte version number. So 4-byte it's also the 38. 4-byte is an int, I believe. So let's look at the integral types. I believe it's unsigned. It's unsigned because the size can only be, well, the version can only be a positive number. So we can just say uint32. uint32. Okay. And then we have the number of entries. So that's another one. Another uint32. Very well. What can we do with that now? What I would like to do is to be able to start to decode that. I'm gonna print the header codec, the code. Oops. The code file byte to bit vector require value. Okay, let's trust. I'm gonna try to replace the. Obviously, does it find the type here? Okay. So now the type that we have is string long. So apparently this one is a string and not a char, which is a bit strange. Maybe it just so it's suggested that it's the apply method. So bit vector. Let's see if it's better now. I hope so. Now we are compiling. So cannot acquire bits from a vector that contains IP4S. Okay, IP4S. Is it in that? IP4S headers. IP4S. Was it IP4S? Or I don't remember. Okay. Okay, so maybe the answer here is just use constant. Constant. And the constant is dir. And then we have these two numbers. Bunch of bits, but can it take bytes as well? Constant byte vector, bit vector. Okay, so I'm just gonna wrap that in bit vector. Maybe there is a way to do that a bit more elegantly, but I am not too sure about it. So bit vector, get bytes. Let's try again now. So I finally found a solution for what I was looking to do here. So I started by looking at UTF-8 and UTF-832, but I figured out quickly that it wouldn't be possible because from what I can understand, and I'm sure that's quite correct, but the UTF-8 doesn't know when to stop, and the UF-832 knows where to stop because the information of the length to collect is in the byte, but not it's not in the git index file. It's something to be used when we it needs to be explicitly in the encoded version, obviously. So I ended up using constant. So the first one is going to constant that I created a bit vector from the string, and then we have the version, and we also have the number of entries. So what I've seen as well, so from that we could see that the result that I have here is 2 and 24. 2 is the version and 24 is the number of entries, which sounds correct. So from now, what do I want to do? I'm going to look at the examples here again. We can see here that there is, the first thing that I want to do is to add this documentation. I believe that it is documentation here. So we need to, whoops, sorry. Documentation. So I'm going to wrap that into parentheses and add how do they call that in the Git documentation? It's the signature. Header signature. Header signature, very well. The next thing is the version, and so if I want to be consistent here, I'm gonna prefix by the what it is. Is there a better way to present that? If we can have something like that, it'd be great. Okay. Let's see if it changed anything to put that in the result. Okay, didn't change anything. So it looks to be just for documentation purposes. Oh yeah, it's to add the context, right? So if there is an error here, let's say that I change that and remove the C. What I'm expecting is that it's going to tell me that the constant is not right. Okay. Okay, so that's interesting. There is no check of the constant. That's strange. So now I would be looking to reuse this number of entries here and potentially the version later on. To go through all of them, I'm gonna wrap that into parentheses and then oops. So what can we do now? I'm gonna call map. Okay, so here we're doing a decoder. So I'm gonna use the map because I'm not interested for the moment to encode. It's gonna be another problem. But like later on we see that we can use either this one or this one, xmap or xmap to define the encoding and the decoding. But let's say for this one we're just interested in the decoding, and we are receiving I don't remember if in Scala 3 we can have that or we need a case or not. Okay, I'm happy with that. What I want to do is continue looking at the documentation and start to parse the index. So index entries are sorted in ascending order on the name field, interpreted as a string of unsigned byte. So that's important. No localization, no special casting of directory separator. Entries with the same name are sorted by their stage field. Okay, so there is a stage field. Okay, so the first thing is the C time second. C time seconds, and it is so it's unsigned. Okay, fair enough. Unsigned int 32. So we can see that Copilot is suggesting all the other names. So let's take a look. Then we have C time nanoseconds fraction 32. Then we have aim time seconds 32 as well. Aim time nanoseconds fraction. Then we have dev, I know, mode. Okay, so the mode here might be slightly different. Okay, the mode is here. 32 bits mode split into high and low bits. So the mode seems to be 4 bits of the object type. Does this add up to 32? 7, no, it's 16. This is 16 if I'm correct, bytes. 16 bits. Okay, so that's where I was telling that this documentation is a bit confusing. He is suggesting 32 bits. I just don't know how to read it correctly, potentially. And here there is 4 bits of object type, and then 3 bits unused, and then 9 bits Unix permissions, but this adds up to 16 and not to 32, so that means that potentially some bits are ignored. Does it suggest that it's a bit in the middle? I'm not sure. Okay, I'm gonna keep that for the moment and see what we have. We said that the mode is potentially not correct. We have the rest is then. So we have the 32-bit UID, key ID, 32 bits file size. Okay. We have so after the file size we have the object name. We have the object name here according to the documentation. That might be missing. The flags uin16. This flag, so 16 flags. So this looks to be better. This sums up to 16. Okay, so that's where we are going to need the version again. For the moment, we don't have that, so we can skip. Maybe it's going to be easier here because there is the indentation that looks a bit better. Okay, so the documentation is actually not up to date, or the version that I chose is not right somehow. So then I have the SHA-1. 160 divided by 20 is 8. So that sounds like it's the 20 bytes here. Then we have the flags, which is 16 bits. Then we have a path variable size. Okay. So that might be a good first throw. Let's see what we have. I don't want that. If I try to run that, what do I have? Okay, so that's really nice because I actually have everything. So I have the context here, that helps, but I don't have the values. But it looks like it's actually, so I'm probably not using the right operator here, I believe, because it looks like it's just combining It's just returning the decoder instead. There was a flat prepend. What is this function doing exactly? Codec. Okay, so what I believe is going to be doing is going to keep the results that we had before. Let's see. Path. So the path is problematic here. I am going to comment it out for the moment. That's much better indeed. So we still have the version, number of entries, and then we have the different daytime. We have the SHA-1. So we can see that we can here start to decode the file a bit. This is the first for me to parse some bits and bytes, and it's a bit weird, it's a bit strange. I'm not used to that, so I am going to leave it here for today, and we're going to continue that in a later next episode. Thank you very much, and have a great day. Bye bye.